Hello everyone, my name is Dr. Koteshwar Rao. I completed my PhD from Jawaharlal Nehru Technical University in the Department of Nanoscience and Technology. I have 15 years teaching experience. First I completed my MSc Physics from Nagarjuna University 2005. From onwards, I am in teaching field. Firstly, I worked as an assistant professor in Avanti Engineering College for 2 years. After that, I worked as a JB8 Engineering College in Hyderabad. There I worked for 5 years. Apart from teaching, I studied my PhD during my in Jawaharlal Nehru Technical University. So now today I am going to explain about the small topic on photoelectric effect. The photoelectric effect, before going to explain about photoelectric phenomena, first of all, we should know what are the alkali elements. So we know that the alkali elements in periodic table such as lithium, sodium, potassium. So these are the alkali elements are used in photoelectric phenomena. So why we use alkali elements in photoelectric phenomena? So let us consider any one metal like lithium or sodium or potassium. When we take any metal and whenever the certain frequency of light, and here we are using certain frequency of light, say here E equal h nu. So this is the frequency of light. When it is incident on here, certain amount of number of the electrons are ejected from the surface of the metal. So the emitted electrons generally we call as photoelectrons. This phenomena it is called photoelectric phenomena. The photoelectric phenomena mainly in which the certain amount of frequency of light it is used. That light when it is falls on alkali elements, from the surface of the alkali elements certain electrons are ejected from the surface. So these electrons are called photoelectrons. This phenomena it is called photoelectric phenomena. This is explained by Einstein in the year 1905. Now let us study about how these electrons are emitted from the alkali elements. So for example, let us consider lithium, and we know that this is the one of the alkali element, lithium. We know the atomic number of lithium, it is atomic number it is 3. The electron configuration 1s2 2s1. So this is the electronic configuration of lithium. Now here we have 2 electrons, say here this is 2 electrons are filled in inner orbit, but on outer shell only one more electron is present. Whenever certain frequency of light where according to that certain frequency of light of energy where it is h nu, when it is incident on outermost shell, what will happen here? That electron, it is the free electron, it is ready to absorb the incident photon, and that electron is coming out of the surface of the metal. So here, this is the way the electron can release from the surface of metal. Now let us say here that instant photon of energy where E equal to h nu. This is the instant photon of energy where h is the Planck's constant, where the value equal 6.6 into 10 power minus 34 joule second. This is the Planck's constant where nu is the frequency of the photon, where here the frequency of photon. So where here this is the instant photon of energy. So this is the instant photon of energy, h nu is equal the certain amount of energy it is used as a work function. The rest of energy used to release the electron from the surface of the metal surface. So here it is the W naught, this is the work function plus of mv square. So this one is h nu is the instant photon of energy, that should be equal to the work function W naught plus of mv square, where W naught is the work function and here it is work function. The work function, that means here, where here the minimum energy is required to liberate the electron from the surface. So that minimum energy, it is called work function. The work function, it is different for different metals. If you take sodium or lithium or potassium, each and every metal has different work functions. Depends on different work functions, the number of electrons also it will affect on work function. So here it is W naught is the work function. We can write here h nu naught, where h is the Planck's constant, where nu naught is the threshold frequency, and here where nu naught, it is called threshold frequency, where here this is of mv square, this is the kinetic energy. Kinetic energy is equal to of mv square kinetic energy of electrons. So the kinetic energy of electrons, where here this is the instant photon of energy h nu is equal to the work function h nu naught plus of mv square. Now we can write here h nu minus nu naught, where nu is the instant photon of frequency, this is the threshold frequency, h nu naught is equal of mv square. So this is the photoelectric Einstein equation. Photoelectric Einstein equation. So in terms of frequency, that means the emitted electron velocity of kinetic energy of emitted electrons depends on frequency. So here this is the phenomenon, this is the photoelectric Einstein equation. Now let us study about what are the laws which are present in photoelectric equation. So the first one is, whenever the photons of energy instant on here on surface of the metal, the electrons are immediately released from the surface. That means there is no time lag between instant photon and emitted electrons. So that is the first one. There is no time lag. There is no So there is no time lag between instant photons and electrons. Once the light instant on photons, metal, immediately electrons are ejected. So there is no time lag. It is in nanoseconds. Second one is the number of electrons emitted by the surface, the kinetic energy. The kinetic energy of electrons, what it is, it will depends on frequency of instant light, and here the kinetic energy of electrons depends on instant light. And here the third one is, and here suppose if the number of electrons when it is emitted from the surface, the number of electrons, suppose if you increase the intensity of light, if it is more intensity, then the more number of electrons are ejected from the surface of the metal. So that means here the increasing of number of electrons generally depends on intensity. So here if so these are the main principles which are involved in photoelectric phenomena. So here there are three phenomena. One is there is no time lag between instant photons and the releasing electrons. Second one is the releasing electrons have certain kinetic energy. The emitted electron kinetic energy depends on frequency. So the frequency, if it is more, the kinetic energy of electrons also increases. And whereas the intensity is, suppose if the more intensity of light is more, the more number of electrons increases. So but not, it is independent of frequency. These are the three principles which are involved in photoelectric phenomena. So generally the photoelectric effect generally we are using in burglar alarms, in which we can use the photoelectric effect. Okay, this is my conclusion. So just I want to introduce for 5 minutes what I explained this. Generally here the photoelectric phenomena, it is explained based on particle nature of light, and it is explained based on quantum theory of light. And here mainly this photoelectric phenomena, when it is a certain amount of light is used on the alkali elements, the electrons are ejected. The ejected electrons have certain kinetic energy. That kinetic energy depends on the frequency of light, and the instant frequency where E equal to h nu is equal to h nu naught plus half mv square. That h nu is the instant energy h nu, where w naught is the work function, where equal to half mv square. The work function means that much of energy is required to liberate the electron from the outer surface of the metal. So the different metals having different work functions, and here from this we can get the Einstein equation. So these are the three laws which are conclusions for photoelectric phenomena. So one is there is no electrons, there is no time lag between instant photon and electrons, and the emitted electrons depends on frequency but not intensity. Suppose if the number of electrons are increases by increasing of intensity but not frequency. So this is the